In this video, I'm going to go over the solutions to 2024 SQA Higher Maths Exam Paper 2. Question 1. We have a triangle ABC with these vertices. In part A, find the equation of the median through B. Now, a median of a triangle passes through a point and the opposite side's midpoint. So we've got to find this midpoint M. Now it's on AC, so all we need to do is find the average of the x coordinates and the average of the y coordinates. So we have M will be -3 plus 11 divided by 2, 8 plus 0 divided by 2, and that gives you 4 as the midpoint M. The next step is to find the gradient of BM. The gradient of BM is given by the difference in the y coordinates of M and B over the difference in the x coordinates of M and B, and we have 4 take away -6, there's a 4, there's a -6, and then this 4 take away -1 is this one. When we do the top we get 10, when we do the bottom we get 5, so the answer is going to be the gradient of that line is 2. The last part then is to find the equation of that line, and we use the formula y minus b equals mx minus a. So we have m is equal to 2, and AB, I'm going to use this point here for 4. So we get y take away 4 equals 2 bracket x take away 4, multiply out this bracket, we get y take away 4 equals 2x take away 8, and then tidy it up a little bit, so we say y on its own will be equal to 2x take away 4, because this -4 goes across, becomes plus, and then -8 plus 4 gives you -4. That's worth 3 marks. Part B. We want to find the equation of the line shown here, and it's perpendicular to BC and it passes through C. So the first step is we've got to work out the gradient of BC. Well, there's B and there's C, so it's going to be 0 take away -6 over 11 take away -1. That's going to give you 6 over 12. You cancel that down, you're going to get gradient equals 1/2. We want the perpendicular line L, so we can say the gradient of the perpendicular is -2. Why is that? Well, M perpendicular times the gradient of BC must equal -1. So when you multiply 1/2 by -2 here, you get -1. Now we want to find the equation of the line, so we just use the equation y take away b equals m bracket x minus a. We have m here, and we've got a point here, 11, 0. So we just say y take away 0 equals -2x take away 11. Just multiply out the bracket and tidy it up. So we say of y equals on its own. When you multiply the bracket out, you get -2x plus 22, and that's worth another 3 marks. Part C, it says determine the coordinates of the point of intersection of the median through B and L. So we did this in part A, that was this one, and then we did this one in part B. So we can say we have 2 lines PB, and then we have PC. This is part A, this is part B. Now solve them simultaneously. Just all we can do is just say that they're equal to each other, because this is an expression for y and this is an expression for y. So 2x take away 4 equals -2x plus 22. So we can say 4x, take this x to the left and then take the -4 to the right. We get 4x equals 26, so x equals 6.5. We want to find y now, so we just go back to the first equation. That's probably the easiest one. So we then say y equals 2 times 6.5 take away 4. That's 13 take away 4, so we get 9. So we've now got the point of intersection. The point of intersection of this line is 6.59, and that's worth 2 marks. Question 2. A curve has equation y equals 8 over x cubed. Find the equation of the tangent to this curve at the point where x equals 2. The first step is to say y equals f of x, and then bring this x to the power 3 up, so it becomes 8x to the power -3. We can now differentiate this. So we differentiate this, so we bring the -3 to the front, the 8 stays in the middle, and the power of x is reduced by 1 to give x to the minus 4. This x to the minus 4, I can bring it back down in the next step, so we're going to say it's a negative number. 3 times 8 is 24, and x to the negative 4 goes down to become x to the positive 4. Now we know that the gradient of the tangent when x equals 2 is given by f dashed of 2. So we're going to replace this x here by 2 to get m. So f dashed of 2 will be equal to negative 24 over 2 to the power 4. 2 to the power 4 is 16, and then we can divide this down by dividing by 8. So we get negative 3 over 2. And negative 3 will be the gradient of the line that we're looking for. We now need to find the y coordinate. So we say when x equals 2, the y coordinate will be 8 over 2 cubed. 2 cubed is 8. 8 over 8 is 1. So it's going to pass through the point 2, 1. So we've now got the gradient here. We've got the point there. To find the equation of the tangent, we say equation of tangent at this point 2, 1 will be y minus b equals mx minus a. We have the m here and we've got the point there, so just we say y take away 1 equals negative 3 over 2x take away 2. The next step is to multiply the left hand side and the right hand side by 2, so we get 2y minus 2 equals, and then multiply by minus 3, minus 3x plus 6, and then we tidy up and say 3x plus 2y take away 8 equals 0, and that's worth 5 marks altogether. Question 3. The coordinates of points D, E and F are given by these coordinates in 3 dimensions. Express the vectors ED and EF in component form. So let's start. ED is equal to position vector D take away position vector E. This is position vector D, we get it from the coordinates of D, and this is position vector E, which come from the coordinates of E. We just subtract them and we get the answer 1, negative 4, 6. 2 take away 1 is 1, negative 3 take away 1 is negative 4, and 4 take away negative 2 is 6. Now we do the same for EF. So EF is going to be equal to position vector F take away position vector E. Here are the coordinates of F, so this is a position vector for F. E again is there, so 3 take away 1 is 2, 2 take away 1 is 1, and 1 take away negative 2 is 3, and that's worth 2 marks. Part B is in 2 parts. The first part says calculate the dot product of the 2 vectors in part A, and then hence otherwise calculate the size of the angle between them, which is angle DEF. So the dot product will be changed to component form, and then calculate the dot product like this. Multiply each of these together, each of these in pairs together, and then add them up. So you're going to have 1 times 2 is 2, negative 4 times 1 is negative 4, 6 times 3 is 18. Then you find the answer to that, so that's going to be negative 2 plus 18 is 16. Now the formula sheet gives you this. A dot B, the dot product, is also equal to the magnitude of A times the magnitude of B times the cosine of the angle between these 2 vectors. So we need to find the magnitude of the 2 vectors ED and EF. How do we do that? We say we take the components of the first vector, square them, and then add them, and then take the square root. So it's going to be 1 squared plus minus 4 all squared, and then 6 squared. So 1 squared is 1, minus 4 squared is 16, 36, 36, 16, 52, and 1's 53, so that's root 53. You do the same for EF using the components of EF 213. So you're going to have the magnitude of EF is going to be 2 squared plus 1 squared plus 3 squared, and then take the square root. That's 4, that's 1, that's 9, so it's going to be the square root of 14. Now, we want to find the cosine of the angle between them, so we can rearrange this formula here to make the cosine the subject of the formula, and we get the cosine of the angle between them, DEF, is the dot product divided by the 2 magnitudes multiplied together. So let's put the numbers in. We get 16 from the dot product here. The 2 magnitudes are here and here, so we put them on the denominator. So we now say the angle will be the inverse cosine of this fraction here. Now we need a calculator to do this, so we do shift cosine, and we then want to make a fraction, and we have 16 on the top, come down, and then we have root 53, go to the right, and then multiply by root 14, go to the right, again, close the bracket, and we get the answer. Now I'm going to take the answer to the nearest degree, so the answer is 54.028, so the answer is going to be 54 degrees. So the answer to this will be 54 degrees to the nearest degree. Question 4. The diagram shows the graph of a quartic function, y equals f of x. It has a maximum turning point at -1, 3. The graph of y equals fx also has a point of inflection at x equals 2, that's down here. So we want to determine in part A the coordinates of the maximum turning point of the graph of y equals f of x minus 4 plus 2. Now, this new function is a transformation of f. From the first part, we know that the graph is moved 4 units to the right, and in the second part, plus 2 means then it's moved 2 units up. So the point -1, 3, that's this turning point here, which is the maximum turning point, will become, you add 4 to the x coordinate, and then you shift the y coordinate up by 2, so you add 2 to the y coordinate. So the answer is going to be, the maximum turning point of this new function will be -4 plus 1 is 3, and 3 plus 2 is 5. Part B says, on the diagram in your answer booklet, sketch the graph of y equals f dashed of x. So let's make, I don't have an answer booklet, but let's make a diagram. So we've got an x here and an f dashed of x here. Now we see we have 2 stationary points, a stationary point here and a stationary point here. This is our maximum turning point, and this is a point of inflection. But what do we know about stationary points? We know that f dashed of x equals 0, so we can put in here, that has to be 0 there, -1, and that has to be 0 when x is 2. Now we need to consider what's happening as we approach these stationary values from the left. So from the left, this is a positive gradient. When we hit the stationary value, it's a 0 gradient. Between the stationary values -1 and 2, it's a negative. When we hit this point of inflection, it's a 0 gradient, and after that to the right, it's a negative gradient. So we can say from a table, we can say this, we put these into the table. So we can say f dashed of x as we approach that is a positive gradient, that's this one, then it's 0, that's this one, and then it's a negative, that's this one, back to 0, that's this one, and then a negative, this one. What does that mean? It means when f dashed is positive, it's above, when it's 0, it's on, when it's negative, it's below the x-axis. So we can say it has to be above, here it will be on, then it will be below in this part, and then it will be below again after x equals 2. So all we need to do is find a point that's going to have to come down through there. Now it's going to come back up to here again, so it has to go to there, but then it's going to have to come down, so this is a turning point. So the graph's going to look something like this. That's it. So if you draw something like that, you get the marks. Okay then. Question 5, evaluate this definite integral. So the definite integral is from 0 to pi by 7 of sine 5x dx. We go to the formula sheet. If you don't know this already, it's given already as sine ax is -1 over a cosine ax. We go back here, we've got a equals 5, so we can then say it's -1 over 5 cosine 5x from 0 to pi by 7. Let's replace x by pi by 7 and 0 like this. So we put pi by 7 here, and then we take away the same thing with x equal to 0 here. Now, tidy this up, we get negative 1 over 5 cosine 5 pi over 7 plus 1/5 cosine of 0. Why is it plus? A negative here times a negative there gives a positive there. Now we know that cosine of 0 is 1, so that when we come to the calculator, we can just put down all of this as 1/5. 1/5 times 1 is 1/5. So let's get a calculator out. Remember, it's in degrees because we've got pi radians here, so we're going to say negative, make a fraction, 1, come down 5, go to the right, cosine, and then make a fraction again, 5, we want pi, there it is, come down, 7, go to the right, close the bracket. Now, as I said, you don't need to do that all, we just say plus 1/5, so we're going to go plus 1 over 5 because we know that cosine of 0 is 1, so we get 1 over 5, and the answer is going to be for this will be 0.3246 and so on. So let's round it off. We're going to say the answer is equal to 3 decimal places, 0.325, 3 decimal places, and that's worth 3 marks. Question 6. Two variables x and y are connected by the equation y equals ax to the power b. We've got a graph of log y against log x where the base of the log is 5 and it's a straight line. Now every straight line has this form, y equals mx plus c. We've now got 2 points here, we can find the gradient m, so we can say the gradient is going to be the difference in the y's, that's 10 take away minus 2, over the difference in the x's, 4 take away 0. That's what we have here. The top is 12, the bottom is 4, so it's going to be 12 over 4 is 3. Now we don't have y and x. Y is a log and x is a log, so we can change these capital X and y into log y equals m times log x plus c. We've got m, so we can replace that by 3. And the next step is to take the 3 inside the log, which we know that's a rule. We can take that inside and make it a power. So we have log y equals log of x cubed take away 2. Now we want to try to find 2 as a log base 5 number. So we can say it's going to be take away log 5 of 25. How do I get that? Well, 25 is 5 squared. So the log of 5 squared is just a power, which is 2, so that's a true statement. Now we've got a log equation here. What can we do next? We're taking these away so we can divide them. So we can say nothing on the left, that stays the same. We can then do this. We can say the log of x cubed divided by 25. Now we can just take away the logs completely and say y equals going to be x cubed over 25. Now we know then, looking at this, a is a number that multiplies the x, so we've got 1 over 25 for a, and the power is b, so b must be 3. So the answer to this question is a equals 1 over 25 and b equals 3. Question 7. We have two curves that intersect at x equals 2 and we want to calculate the shaded area. So we have a top function here and a bottom function here, and we want this area between them. So the shaded area is going to be given by the integral from 0 to 2 of this equation take away that equation. The first one is the top function and the second one is the bottom function. The top here and the bottom there. Now we've got to find a single expression for this, so we'll remove the brackets, multiply by -1 through the brackets, and we get 6 take away 7x plus 4x squared minus x cubed. How do we get that? Well, we have a 6 here and no other numbers there, so that's where the 6 comes from. The 4x take away 11x becomes -7x. Take away 2x squared, subtract -6x squared becomes plus 6x squared, which gives you plus 4x squared, and then we've got take away x cubed. Now we need to integrate this term by term, and here's what we get. When you integrate 6, you get 6x. When you integrate 7x, you raise the power and divide by the new power, you get 7x squared over 2. When you integrate 4x squared, you raise the power by 1 to get x cubed and divide by 3. that's 4x cubed over 3, and to find the integral of x cubed, it's raise the power by 1 and divide by 4. The next step is to replace x by 2 and then by 0 like this. Now, what I've done here is I've replaced x by 2 here, and I've got minus 0. That's because every term has an x in it, and when x equals 0, all of this will just be 0. So we have to calculate this. Let's get a calculator to do that. So we have 6 times 2, we can just say is 12. Take away 7 times 2 squared is 4, and then divide that by 2. And then we add 4 times 2 cubed is 8, and divide that by 3. And then we take away, well, 2 to the power 4 is 16, divided by 4 is 4, and there's the final answer. It's 14 over 3. So the answer to this question will be 14 over 3. It's an area, so that's square units. Question 8. We have two functions here, f of x and g of x, and we want to find an expression for f of g of x. So f of g of x will be f of x plus 1, because g of x up here is x plus 1. So we will put into x plus 1 into this expression for f here, and that becomes 2 bracket x plus 1 squared take away 18. All we need to do now is multiply out the bracket here, square the bracket here, you get x squared plus 2x plus 1, take away 18, multiply by 2 here, and then tidy it up, we get 2x squared plus 4x minus 16. How do I get that? Well, 2 times x squared is 2x squared, 2 times 2x is 4x, 2 times 1 is 2, and 2 take away 18 is negative 16. Second part says, find the values of x for which 1 over f of g of x is undefined. So 1 over f of g of x will just be 1 over the answer here, which is 2x squared plus 4x minus 16. The next step is to take out a common factor of 2. You get 2 bracket x squared plus 2x take away 8. We then try to factorise this, and we can in fact factorise it. We get x plus 4 and x minus 2. Now this will be undefined when this bracket here becomes 0 or this bracket becomes 0, because you can't divide by 0. So it will be undefined when x is negative 4 or x is 2. So that's the answer. It's undefined when x equals negative 4 and when x equals 2. Question 9. Determine the coordinates of the stationary points on the curve with this equation. So the first step is to go dy by dx, that's differentiate y. We get 3 times 1/3 x squared take away 2, x take away 3. We can multiply these first two terms here to get 1, so we get dy by dx is x squared take away 2x take away 3. We then factorise that into x plus 1, x minus 3. We say stationary points exist when dy by dx equals 0, so we set this here equal to 0. And then we can find the values for x that make that 0. From the first bracket, x is minus 1. From the second bracket, x is 3. Now we want to find the coordinates. This is only one coordinate, so we're going to have to take it back to the original equation here to find the y coordinates. So x equals minus 1 will give us y equals 1/3 of minus 1 cubed, take away minus 1 squared, take away 3 times minus 1 plus 1. And when you use a calculator or work it out anyway, you're going to get a value of 8 over 3. We do the same for x equals 3. Put it into here and we get 1/3 of 3 cubed, take away 3 squared, take away 3 times 3 plus 1. And if we do that with a calculator, we'll get the answer negative 8. So we've got the stationary points on this curve are minus 1, 8/3 and 3, negative 8. Part B. Hence, determine the greatest and least values of y in this range. Now, one of the values here, this x minus 1, is a stationary point. We don't know if it's a maximum or minimum. We're not asked that. We're just to find the coordinates. So we're now going to find out what happens at the other end of this interval. Let's get a value for that. So when x equals 6, let's put it into this original equation to find out what y is. So y is going to be 1/3 of 6 cubed, take away 6 squared, take away 3 times 6 plus 1. Use a calculator for that, you get the answer 19. Now we have three values. At the extreme left, we've got a value of 8/3. In the middle, we've got -8, and we've got 19 at the right-hand side when x equals 6. So we can conclude that the greatest value of y is 19, that's when x equals 6. And the least value of y is -8, and that's when x equals 3. Question 10 says the circle C1 has this equation. We want to find the centre and the radius of C1. So we have this on the formula sheet, and we can see this is the form of the equation, which is going to be the same as this one here. And that's going to give me a centre minus g minus f, and the radius, the square root of g squared plus f squared minus c. So all we need to do is find g, f, and c. So we do it like this. There's the general form we use. This is the equation we've got in the question. We just compare them term by term. So we can see 2g will be equal to 18, which means that g will be equal to 9. And then 2f is the same as -2. So the answer is going to be 2f, -2, f is -1. And c is the number on its own, which is -8. So c is -8. So we can now write down the centre. The centre is given by -g minus f. So it's -9, the negative of -1, which is +1. And then the radius is given by g squared plus f squared, take away c. Be careful because 9 squared is no problem. -1 squared is no problem, but it's take away -c, so that becomes +c. So that's going to be 81. 81 plus 1 is 82, and then you add 8, so that's going to be 90. Let's reduce this to a simplest form. So let's say √9 √10, and then it's going to be 3 √10. So the radius is 3 √10, and the centre is -9, 1. Part B says determine the equation of C2. Now we know the centre of C2 is -6, 0. We need to find the radius. So we know that the centre of C1, let's call it P, let's call the centre of C2 Q, and let's call the tangent point here T. If we draw a straight line, P, Q and T will be collinear, so we can say that the radius of C2 will be given by the length QT, and that's going to equal PT, which is the radius of C1, take away PQ. So PT is replaced by 3 √10. So we have 3 √10 take away PQ. Now all we need to do now is find the length of PQ. So what do we know? We know the coordinates of P and Q. It's -9, 1 and -6, 0. So the length of PQ is going to be the difference in the x coordinates squared plus the difference in the y coordinates squared. And that's what we have here. Be careful, this will be a plus. So -9 plus 6 gives you 3. 3 squared is 9. 1 minus 0 is 1. 1 squared is 1. So the answer is going to be the square root of 10. So we can now say that the radius of C2 will be 3 √10 take away PQ. PQ is now √10, so it will be 3 √10 take away √10, which is 2 √10. So we can now use this form of an equation of a circle, and we can say the equation of a circle is going to be x plus 6 all squared plus y squared equals 40. How do we get that? Well, it's going to be x take away -6 all squared, that gives you the first one. Y take away 0 all squared, that gives you the second one. And the root 40 comes from the square of this radius. When you square 2, you get 4. When you square √10, you get 10. And 4 times 10 is 40. And that's the end of that question. Question 11. The number of electric vehicles worldwide can be modelled by n equals 6.8 e to the power kt. N is the estimated number of vehicles in millions, T is the number of years since the end of 2020, and K is a constant. In part A, use the model to estimate the number of electric vehicles worldwide at the end of 2020. So, there is the equation that we have, n equals 6.88 e to the power kt. At the end of 2020, t is 0 because we start counting the number of years t at the end or from the end of 2020. So t equals 0. This can be put into the above equation and we get n equals 6.8 e to the power 0 because this becomes 0. Any number to the power of 0 is 1, so the answer is n equals 6.8. Don't forget, it's not just 6.8, it's 6.8 million because n is measured in millions. Now, part B says at the end of 2030, it is estimated there will be 125 million electric vehicles worldwide. We now want to determine the value of K. So what do we know? At the end of 2030, that's 10 years past 2020, so T equals 10, and we know the number is 125. We put these two values into the original equation up here, and we get 125 equals 6.8 e to the power 10k. The next step is to isolate e to the power 10k by dividing both sides by 6.8. That's 125 over 6.8. The next step is to take the logs of both sides. When you take the log of an e number, you just get the power, so it's 10k, and this becomes log of this. We want to find k, so let's divide or take a tenth of both sides. So k is going to equal 1/10 the natural logarithm of 125 over 6.8. So we need a calculator to work this out. So let's get a calculator up, and we can say 1/10 is 0.1, and then we're going to go natural logarithm, and then make a bracket and make a fraction. 125 come down 6.8, close the bracket, and then equals. So there's what we get 0.29111, so on. So we can then finish this off by saying k equals 0.29, and I've rounded it to 2 decimal places. That's worth 5 marks in total. Question 12 is a trig equation, and x lies between 0 and 360. It can equal 0, but it can't equal 360. So let's start with the equation that we have. 2 sine 2x take away sine squared equals 0. Now, here are the trig formulae. Which one can we use first? Well, we can see we have a sine 2x, so we can use this formula here, which is 2 sine a cos a. So if it's going to be sine 2x, it's going to be 2 bracket 2 sine x cos x, take away sine squared x equals 0. Next step is multiply this by 2, so we get 4 sine x cos x minus sine squared x equals 0. We can see our common factor sine x here. We take out sine x as a common factor, and we get 4 cosine x, take away sine x equals 0. So we can conclude that sine x could be equal to 0, or the bracket can be equal to 0. Now we know when sine x equals 0 because we should know the graph. It's going to be 0, 180, 360. But of course we can't let it equal 360 because the condition is it's got to be strictly less than 360. So from the first part we've got only 2 answers. X could be 0 or 180. Now to solve this part here, we could just take the sine x over to the other side and get 4 cosine x equals sine x. Now we know that sine x divided by cosine x is tan, so the next step is to divide both sides by cosine x. So we get 4 cosine x over cosine x equals sine x over cosine x. Here the cosine x values cancel, and we get 4 equals tan x. And all we need to do now is to solve that. So we can say x will be the inverse tan of 4. We get a calculator for that. So let's do that now. So we go shift tan 4 and get the answer in degrees. So we get x can be 75.96. Let's just round it off to 76 degrees. Okay. Now, what do we know? We know that won't be the only answer. because we know that this is a positive number for tan, so tan can be in the first quadrant or it can be in the third quadrant. So we had 76 from the calculator, so that will be in this quadrant. So we can say x will be 76, or it will be 180 plus 76. So the final answer will be 76 degrees and 256 degrees to the nearest degree. So your four answers are 0, 180, 76 and 256 degrees. Question 13. The diagram shows the graph of y equals f of x, where f of x is a quartic function. Now we have roots at -1, 3 and 5, so we can say x equals -1 is a root, so x plus 1 is a factor. The next one we can say is x equals 3 is a double root, so x minus 3 all squared is a factor. A double root because it's also a turning point. And then x equals 5 is a root, so x minus 5 is a factor. So we have three factors. X minus 3 all squared, x plus 1 and x minus 5. So we can say f of x equals k times x minus 3 all squared, x plus 1 and x take away 5. All that remains now is to find the value of k, and we do it using this point down here. This point down here, we know that x equals 0 and y equals -9. So we can put these two values back into the equation above. Of course, f of x is the same as y, so we can say -9 is k times 0 minus 3 all squared, 0 plus 1 times 0 minus 5. So let's tidy up the right hand side. K stays as k, minus 3 all squared is 9, 0 plus 1 is 1, and 0 minus 5 is -5. And we multiply out the right hand side now to get the answer -45k. So -9 equals -45k, divide everything by -45, and we get k equals 1 over 5. Because a negative by a negative is a positive, so that's why there's no negative here. So we finish this by saying f of x equals 1/5, bracket x minus 3 all squared, bracket x plus 1, bracket x minus 5, and that's the end of the question paper.